Hi everyone, welcome to today's lesson. I can identify characteristics of an ellipse from their functions and graphs. Let's take a look at the do now. Number 1, find the center and radius of a circle x minus 3 squared plus y plus 2 squared is equal to 4 and sketch it. So this is a circle. Remember, to find the center, you take the opposite signs, 3 comma negative 2, and the square root of 4 is 2, which is your radius. So when you graph the center point, 3, negative 2. And then because the radius is 2, you go up 2, left 2, down 2, right 2. And there's the graph of the circle. Today we're going to focus on the graph of an ellipse and how we would write the function. So let's take a look at all of the ellipses and write their equations. How are the graphs and equations related? So if we take a look at A, x squared over 16 plus y squared over 4 is equal to 1. Now, along the x-axis, if I take radical 16, that's going to be equal to 4. So if I count from my center, which is 0, 0, I'm 4 to the left and 4 to the right, which means my radius. Same idea for the y. If I take the square root of 4, I'm up 2 and down 2. Notice I have a plus sign, and it's equal to 1, which is the structure of an ellipse. Why don't you take a look at B and see how the graph of the ellipse is related to the equation. The 9, which is associated with the x squared, radical minus 3, so 3 along the x-axis. And then the square root of 25 is 5 along the y-axis. Again, there's a plus sign, and it's equal to 1. So this brings us to our definition of an ellipse. An ellipse is a set of all points in the plane, the sum of whose distances from two fixed points, foci, is constant. So again, if you look at the formula or the standard form of an ellipse, x squared over a squared plus y squared over b squared is equal to 1. Plus sign, and it's equal to 1. So if we take a look at the graph, if I find my center point, along here, my major axis would be my A, and my minor axis would be the B. Okay, my major axis is when it's wider. And if it's longer than it is wide, then my major axis would be the y-axis. Let's take a look at the next page. We have more definitions. The first one being vertices. A comma 0, negative a comma 0, 0 comma b, 0 comma negative b, or vice versa. This all has to do with depending on if your x-axis or your y-axis is the major axis. But just notice here are your vertices. Now the next definition is a foci, which is the plural of a focus. It's two fixed points on a major axis equidistant from each other. So for example, the foci are here, and there also can be one here. It's at the same distance from the center. And to find the formula for this, you would use the Pythagorean theorem. So for example, c squared is equal to a squared minus b squared. To get c by itself, you take the square root. So c is going to be equal to plus or minus the square root of a squared minus b squared. Now remember, a is always the larger denominator, so whatever number is larger, that's going to be your a value. And the foci are always on your major axis. So for here, it's on the x-axis because it's wider than it is longer. So this would be your foci in here. Next, you have your eccentricity, which is a measure of how nearly circular the ellipse is. C is the distance from the center to a focus, and A is the distance from the focus to a vertex. So again, C, we just discussed before with our foci. It's plus or minus the square root of a squared minus b squared. It's the distance from the center to the focus. And then A is the distance from the center to the vertex, which is just represented by A. Let's take a look at the examples below. So it says, look at all the ellipses and their equations. How are the graphs and the equations related? Now we know x squared over 16 plus y squared over 4 is equal to 1. My a squared, which is the 16, is larger than the 4, which means my major axis is on the x-axis, so it's going to be wider than it is longer. So again, you count the boxes. My center is 0, 0, and 4 to the left, 4 to the right. And the y squared, the square root of 4 is 2, 2 up, 2 down. And there's my ellipse. Same idea for b. My major axis would be on the y because radical 25 is 5 and 25 is bigger than the 9. So you're going up 5, down 5 from my center 0, 0. Square root of 9 is 3, left 3, right 3. So there's my ellipse when the major axis is on the y-axis. Next, I have my first example. Find the vertices, the foci, and the eccentricity of the ellipse 3x squared plus 12y squared is equal to 12. Then sketch. So notice I need it in the form x squared plus y squared over a squared b squared is equal to 1. Is this, in fact, equal to 1? No, so I have to divide by 12 on all of the terms. So I end up getting x squared over 4 plus y squared over 1 is equal to 1. So my major axis has to be on the x-axis because 4 is bigger than 1. So my center is 0, 0, 2 to the left, 2 to the right. Those are my vertices. 1 up, 1 down. To get the foci, remember c squared is equal to a squared minus b squared, or c is equal to the plus or minus the square root of a squared minus b squared. So the square root of 4 minus 1 is the square root of 3. Plus or minus the square root of 3, comma 0 are my foci. Remember, your foci is on the major axis, so it's approximately here and here. And finally, for my eccentricity, it's E is equal to C over A. My C value is my plus or minus radical 3 over 2, my distance from my A. Radical 3 over 2, and I also approximated with a decimal. And that tells you how nearly circular it is. Why don't you take a look at example 2 and solve the problem. To recap, we divided by 36 in order to equal to 1. X squared over 9 plus y squared over 4 is equal to 1. This has a major axis on the x-axis because 9 is greater than 4. My vertices are plus or minus 3, comma 0 and 0, comma plus or minus 2. My foci is the square root of 9 minus 4, which gives you the square root of 5. Again, because my major axis is on the x, it would be approximately here and here, the foci. And my eccentricity is my foci divided by the a value, which is 3, radical 5 over 3. For example 3, we are given a graph of an ellipse and we are told to write it in standard form. So I count the boxes from my center, which is 0, 0. On the x-axis, it's 2, which is 2 squared, which is 4. And then on my y-axis, which is my major axis because it's longer than it is wide, 5 boxes up, 5 squared is 25, giving me this as my standard form. I find the domain and the range based on the graph, my vertices, and my foci. I did radical 25 minus 4, which gives you radical 21. I did make an error here because remember we said our major axis is on the y-axis, so my foci would be here and here. So that would be 0, comma, plus or minus radical 21. And again, to find the eccentricity, it's C over A plus or minus radical 21 over 5. And take a look at the second example as well. For the foci, it should be 0, comma, plus or minus radical 5, because again, it's longer than it is wide, so my foci would be on my major axis, which would be the y-axis from the center. Here is example 4, with writing in standard form, finding the domain, the range, the vertices, the foci, and the eccentricity. Remember, the answer key is posted on the Wakelet as well. Feel free to message me on Teams with any question. Thank you. Have a great day.